One of the key points of a good study regimen is to not simply gather and learn information, but then to go ahead and to maintain that information. One of our key goals of studying is to build our ability to remember information quickly, accurately, and for a long time. And so we have to work on each of those carefully. Um, Remember from Eddingbass that information decays over time, but if we go ahead and review that information at key intervals, i.e., return it back to 100%, that information then decays more slowly over time. And that's what, so what we have to do is we have to space and then retrieve the information that we're trying to learn. So, generally speaking, for new information, it is about 3 days where you have to go through that process of reviewing that information. So, generally speaking, that review has two parts to it in mathematics. One is reviewing your notes, and two is practicing questions uh, based upon that information that you have. So, after you've gone through that review process, you've gotten all your questions answered, you can, i.e., you can answer all questions correctly, you can explain all questions correctly, and you can teach all questions that are all information to anyone that you need to know. After you've gotten to that point right here, what happens is you then want to push that information over to a weekly review. Generally speaking, from your notebook, once a week, every week, you want to go back to page one and you want to review that information. And that review from page one right here onwards is what we call an active review. So in that review, what you'll be doing is you'll be asking yourself questions about the information that you're trying to understand. You will be you'll be asking yourself questions about the knowledge and about the connections of the information that you're reviewing. You would check your recall for accuracy. So you might cover up your notes and ask yourself, well, how do I solve this problem? And if you can correctly recall the steps to solve the problem, that's great. If you're not, then you know that's something that you need to spend some more time on reviewing and understanding. Uh, you can also actively recall in several other ways, but also you need to definitely want to make sure your evaluation and synthesis and analysis of information is correct. Sometimes we believe we learned something, but after more time and more seasoning and more practice and differentiated questions, we might recognize our understanding was slightly off. And so at that point right here, we want to adjust our knowledge and our recall to make sure that we're coming up with the right answers. Often that happens when you move to the harder questions, if you have ABC, the level C questions, in the information that you're looking for. You're no longer just adding A and B together. You know, the first level questions, you're being asked to create and to think about how different ideas fit together. And sometimes the way you thought they fit together is not exactly right. And so you have to go back and adjust your knowledge and understanding to make sure it's all right and it all makes sense. And again, part of that process right here is that you have to go back and create memory aids for stuff that you're having a hard time to learn, a hard time learning. And you want to, so that can help you learn things faster and help you can understand and keep ideas and concepts straight in your mind. So that's one of the things that you definitely want to do. Um, you also want to then practice well. Mathematics is a very precise concept and very precise in its structure. And so, because of that, you have to take the time to practice problems. One of the best ways to do that is to review and rework problems that you have already reworked in the past to help make sure that you're understanding everything that you're doing. Obviously, you want to work on speed. So if you can answer a question in 5 minutes, try again and answer a question in 3 minutes. If you can answer a question in 3 minutes, try to answer a question in 2 minutes. Try to build your speed without making mistakes. Uh, try to build your speed, but still being able to accurately recall what you're doing, even under that pressure. Also, you want to work on the testing conditions. Normally, at home, if you work one problem, after you're done, you can go back and check that answer. But it's a different kind of stress when you have to work three, four, five, six problems in a row before you can go ahead and see if you're working them correctly and see if they're all fit together. And so sometimes you want to go ahead and put yourself under testing environments. Of course, you want to always try and explain answers out loud whenever possible, or at least explain to a friend. You want to go ahead and take um, practice exams to make sure that you're working through and completing the test in a timely manner. And one of the best ways to create your own test. Creating your own test is first of all important because you can figure out what you need to know, and but also you can challenge yourself. You know that this is a weaker part of your knowledge. You can put more of those questions on there. You want to write out your answers properly. You don't want to just write down x equals 5. You want to write out all the steps carefully and properly, just as you would write out on a test. But also understanding the meaning behind each of those steps, because mathematics, you just don't write stuff out. We want you to make sure you're understanding how and why those things fit together. And of course, you want to always recognize any connections between ideas and concepts. You're looking at an exponential graph. Well, an exponential graph is a graph. So all the ideas that follow from your learning about graphs, x and y coordinates, x is the input, y is the output, all of that information holds when you're talking about exponential graphs, for example. And so that help you understand and explain what's happening when you're looking at, for example, y is equals to the 2x graph. Of course, you can always be the teacher. So for any concept and idea, it's always good to create um, example presentations. Imagine if the teacher said, this is for a grade, and you come in front of the class and explain the ideas and the concepts behind this topic. And that helps a lot in terms of you can talk out loud and think through how things are connected and how you would say them in sequence. Those things are important in helping you understand what's happening. Again, one of the things that you can do to this active practice right here is to create a study group, and you quiz each other. Each person creates questions and the other people try to answer those questions and poke holes in the question. Why does this question not make sense? Why is this question good for you? Definitely, definitely. You want to spend some time giving back, tutoring, and helping others. This not only helps them, but it helps you a lot. And last but not least, you want to go ahead and look for real world situations. Look, that's a quadratic equation. If you see a curvature, you might be able to set that to a quadratic equation. How would you do that? How would you look at that motion of that basketball going into that hoop right here? How would you create an equation for how that motion is moving? What would you need to know? Who would you need to ask? These are all important parts of you being able to actively prepare, learn, and use the information that you have acquired.